Okay. All right. So good evening, everybody. Thank you.
Very good.
Yes. Thank you for joining us.
Can call in mommy. Oh, the parents.
Oh, I just have to mute that.
I will give me by email.
All right. So thank you everybody for joining us today. For day two of this machine learning bootcamp. On the first day, we started at looking at the fundamental concept of AI agents, in which uh, we had a number of turn up and we explored how to get started building AI agents. So I'll just share my screen so we do like a brief overview of what we did on the first day. So on the first day, um, we talked about we talked about what AI agents are. Quickly, we also explored what we mean by reasoning. Okay, we also explored what we mean by reasoning and LLMs having the ability to reason. So for today, we have our speaker here already, and we are going to be doing hands-on demo. Um, it will be hands-on on integrating AI agent. Okay, so let's say yesterday on day one, we covered the basics and understanding of AI agent. So today we are going to look at how do we now start building, how do we now integrate AI agents into what we are going to do today. So I can see in the chat section that there is a comment to tap on what AI agents are. So I'll just quickly go through that so everybody can have the hands on or for so that even if those that will not be on the first day, they will be able to um, not miss out on what was discussed on the first day. Right. So I'll just share my screen and we will. All right. Cool. I believe you can all see my screen. Yes, so for today we have a speaker here, and on the first day we understood that AI agents are they are autonomous agents. They are agents that have tools. They can interact with environment. They can also you know think set up a list of tasks, a list of plan, and then go ahead and execute that task. We also looked at reasoning. They are using React reasoning, that is using React for the prompt and giving it these thoughts that it will be able to not just go on the straight road because the what really makes it an agent is the fact that it can iterate over a list of process. And then we also look at observability. Okay, we also looked at observability and talking about theoretical foundation of AI agents. We have cognitive psychology. We also have system theory. We have decision theory, and we have guides to relational decision. Okay, so also AI is also about self-governance and independence, decision making, self-directed action, goal communication, independence, reasoning, minimal human intervention, and the whole lot. So we also have reactivity in AI agent, dynamic adaptation to environmental changes, using tools, using real-time sensors, real-time sensor environment. For example, we also explored the code agent that have the code agent, okay, kind of agent that uses code as a tool. So in this particular concept, how does it react to its environment? So those were the things we discussed. We also saw an example here where we talked about different prompts and different approach, whereby we had first response using zero shot cut, that is using the React app code, right? So finally, we also saw different agents in action, agents using text and agents using LLM. Okay, so basically this is a quick recap and overview of what was done in our first class. That is on the one. So today we are going to our speaker is here already. So without wasting any further time, I'm going to bring on our speaker on stage, Mr. from Python Anambra, Mr. Felix. So Python Anambra, one of our partnering communities. Let me go back to our first slide we have here. So these are our partnering communities and the entire team making sure that this bootcamp is brought to you. So special thanks to Python community Anambra. Also special thanks to Python community Yo. Special thanks to Talents AI, Computer Vision Africa, and our distinguished speakers who have who are in one way or the other, they have done well to make sure that this bootcamp is currently running. So we are going to have a speaker now, Mr. Felix from Python Anambra to take us on creating AI agents. So Mr. Felix, are you there?
Yes, I'm here. Good evening, guys. Can we hear me clearly?
Yes, I can hear you.
Okay, all right. It's nice being with you guys, and I'm also happy for sharing some knowledge with us on agentic AI. So, as we know, recently agentic AI is the current trend in AI systems. So, without wasting much of our time, because we have a whole lot of things to cover, we'll be jumping to what we have today. Let's know that today's class is fully hands-on. So we'll be writing codes, we'll be running codes, and we'll be seeing what this agent is actually all about and how an agent can run. So that's what we'll be doing now. So Victor, I'll be sharing my screen right now. So
All right. So at this point, I'll turn off my video and go completely off the stage and take over. So feel free to ask your question, drop your question. I'll be going through the comment section to address any potential issue or question anybody has. All right. So thank you.
all right, thank you very much. All right, so I hope we can see my screen, right? If you can see my
Yes,
screen, can I see a thumbs up?
I can see your screen.
Okay, thank you very much for that. So just like I said, we'll be doing a practical hands-on. So, but before we continue, I would like to show us something. So let's look at this particular slide here. Okay, so it's taking some time. All right, so this is how we make use of a traditional LLM. Okay, this is how we make use of the traditional LLM. Make use of the traditional LLM. You send a query to an LLM, and then the LLM will give you a response. I believe that every one of us here knows what an LLM is. So every one of us here knows what an LLM is. So this is just what our fundamental LLM is. We make a query. We all use ChatGPT and different chatbots. So it's just a normal generative AI, okay? Now, when we talk about an agent, is we know that this LLM, their knowledge, it's quite limited. So it's only based on what it has. It will not be able to perform much task. Okay, so but when you now bind this LLM with different tools, then you're actually building what is called an agent. So this LLM will now use these tools to execute different tasks. So this is what an agent is, okay? So I just wanted to show us this slide so that we can understand something about agent before we actually come down to the code. All right, so let me all right, so now let's come down to the coding aspect. Okay, let me say again. Let me zoom this here again. Okay, let's come down to the coding aspect. So the first thing we're going to try is we're going to query LLM. Okay, so we're going to see, we're going to query LLM. Let's know what they are. But then you need to understand something. There are 4 building blocks for an agent. We have the planning, memory, tool, and action. This is the loop in which an agent takes to execute whatever it's doing. So we have first of all, plan the job it needs to do. Let me take, for instance, you have an agent that needs to execute a task, maybe run as your assistant, and it needs to book a flight for you. So it's going to plan on how it's going to execute the task. We have a memory so that it can actually retain the execution, so that if we have a context of what it is doing, it now makes use of tools to execute this task, and it makes action. Action is when it does this too. These are the building block of agent. So to make use of elements, you need to initialize your API. Okay, you need to initialize your API. So I'm going to share this, and you can run it on a Jupyter notebook. So this is a Jupyter notebook on VS Code. So if you can run a Jupyter notebook on VS Code, or just run the Jupyter notebook on the browser, it's something. So you need to initialize your API. Okay, so I'm working with OpenAI. Right, so my is in this .env file. Okay, but I'm showing how you set up the env file. It's very simple. So this is in case you want to do your now. I don't want you guys to see my API. So this is just how it is. So one of the variable I have here is OpenAI API. So when you come to your own file, you just write this OpenAI API is equals to, then you paste your AI key just okay, and you are good to go. So there are many other LLMs you can use. There is Group, Clouds, Gemini. What you just need to do is to get the API key. Okay, so I'm working with OpenAI, so you can. I have the OpenAI API key here. So I'm going to run this cell. Okay, and then after setting up my API key, let's initialize my LLM. So I'm working with LangChain. So this is how you initialize LLM on LangChain. There are different ways you can initialize different LLM on LangChain as well. So you can actually check that out on their website. You may not be able to start checking it out one after the other because it might take some time. Someone is asking a question whether I can show how you obtain the API key. You just go over to OpenAI playground. just go over to open AI and okay, let me just so this is the OpenAI API playground. Okay, so just come to OpenAI API playground. Come to the playground. No, not the playground. Sorry, come to your dashboard. Okay, come to your dashboard and then you come down to API keys. I come down to API keys. You can actually create a new API. So I can create a new API key here. So once I click create a new API key, then I will just copy the API key. So immediately it creates, you copy the API key. Okay, so that's how I got my API key. Then you can actually so once there are different methods you add your API key. Okay, there are different methods you add it. So, but this is one of the methods, adding it to the environment variable. So it's pretty easy for you to do this way. Add the API key, then initialize the LLM. So this is the LLM. I'm using OpenAI. So and the variable of the LLM is LLM. So if I want to invoke this man, if I want to invoke this LLM, I'm going to say LLM.invoke. That is if I want to query it. Okay. If I want to query the LLM, I'm going to say LLM.invoke. So let's query this LLM now. Let's ask it this question now. So what is Agentic AI? All right, what is Agentic AI? And I will run this, and it's going to query this LLM through my API key. So it's done running. That means it's gotten me this response. So let's see what this response has. So if I try to run this response, we see that it returned an object of a class AI message. So this is what the LLM returns from LangChain AI message. So and this is the content. So when we look at this very well, this is the content. The content is the message that I got from the LLM. If we scroll down, we're going to see the model that made the query. I'm running 4.1 nano. So it's GPT 4.1 nano. And we also see the metadata, usage metadata, and token output details and all that. All the details that that took this particular call to execute. We'll get all of them here. So I can decide to get only the response. So what I will do, I will just say print. So we see that this object here has a value here, content. So I'll just say response dot content. So and I will get just the contents of the output, which is the meaning of agentic AI. Agentic AI refers to artificial intelligence system that processes blah 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 blah, and we are getting everything out here. So this is how you can just do a simple query to your LLM and you get a response. So I know why I just ran this, but you see that LLM will be able to respond to just the query that I gave it here. It can't perform any other task. So how does it perform tasks? So let's go ahead. Let's build a graph. So what is a graph? So what is a graph? So let's build a graph. So let's first of all, we're going to build a simple graph. Okay, we're going to build a simple graph. So what is a graph? In LangChain, LangChain has one of their product, which is LangGraph. So if you LangGraph is one of the libraries that you can use to develop agents. So it helps you to build what we call a workflow. You know what a workflow is? A flow, how the work will be done. Okay, so if the agent wants to do its job, it knows that, okay, I should do this first. After this, I should do this second. After this, I should do this third. So that is just a workflow of how an agent works. So building a simple graph, so we need to make some of all this import. So from line graph.graph, we're going to import the state graph, start. This start and end is always signify the start of the task and then the end of this task, and then this message state. Okay, I'm going to explain this message state. So this is from IPython.display, import image and display. This is just to display the graph when we've built the graph. Okay, this message state is a schema, is a message schema that the graph will be using to work. Just like I explained, the graph is just like a workflow, allowing you to build after the first one, the second one should execute, and then the third one should do what? Execute. So for these executions to actually work properly, it needs to be able to pass messages from one, workflow to another workflow, from the next one workflow to another workflow. So it needs a kind of a structure that will enable you to do what? Pass these messages from one workflow to another workflow, from one workflow to another workflow. So that is what the message state does. So it's just a message scheme for the graph. Okay, so now this is a function. Okay, this function is just is going to be serving as one of the nodes in the graph. So what this function does is just like what we've done here. Invoke the LLM with a particular prompt and then get the response. So it takes a variable, it takes this message state. So this message state has one of its variable. So it has one variable in it called messages. Okay, so this messages is where all your messages will be. So if I'm invoking this graph, I'll be passing it just okay. Let me show us how this let me show us how this message state is. This is how this message state is. It's just like me creating a class, calling it message state, and then it's going to be taking a typed dict, and then I will have to define a variable here, messages of type annotated not this list, and then it's going to be having a message reducer, which is add. So this is just most of these libraries are not imported there. This is just the structure of how the thing is, okay, of how this message state is. This is the class variable that I will be calling. So I just want us to know that it has a class variable called messages that we're going to be doing what? We're going to be referring to. That is why when we are performing this LLM.info, you know that this function is taking an instance of this message state. We are trying to read these messages. So any message it has, it's passed it to the LLM, and then it gets a response. Okay. And what we are returning something that looks like the message state again, having these messages, and then we return this. So I'm just trying to explain this so that when we continue, it's my it might be a little easier for us to follow. So this is just how the thing is. So I'm going to run and execute this, and then this is the graph. So this is building the graph. So this is the state graph. Then adding here we have only one node. We add the node. We're calling the node LLM core, which is this function we have here, LLM core. And then look at the graph. We'll start from start. You go to LLM core. Then from LLM core, you go to end. So I'm going to run this, and this is just how the graph is. We're using this display to show the graph. So this is just the graph. Okay. So I can easily make a call to this man here. So let me just ask it a simple question. What's the product of the product of 2 and 3 add 6? What's the product of 2 and 3 added to 6? Okay, so I'm going to ask it this and then it's going to execute it. But then I introduce something here. We have, is anybody saying anything? We have a human message here. So this human message is just a class that this LangChain is using to differentiate the message that the human type and then the AI response. When we ran this here, we saw that it returns, when we try to get this response, we saw that it returns an AI message. Okay, let me show. So let me just print this response again. So I have here. So we see that it returned. Okay, I think I've executed something. Okay, let me run this again and then run this. Okay, so it's like it has an AI message. So that is the message coming from the AI. So if we want to differentiate that coming from the human, we'll create a human message. And then the content is what's the product of 2 and 3 added to 6. So let's run this. So once it's done running, we're going to be printing this response. Okay. Where are we? So this is the response here. Okay. So this response is showing us a list of messages. This is the key messages. This is a dictionary. This is a dictionary and showing us a list of messages. This is the messages, okay? And this is a list of messages. We're having human message and AI message. All right, so when we look at the human message, there are no user metadata here. But when we check the AI message, we have metadata because it's actually queried the AI. So we can just iterate the response.messages, which is this list of messages, to get the messages using prettyprint. So prettyprint is the method in the LangChain, so that will help you to print the message. Look at how neat it is. So this was the question, and then this is how it executed to get the answer or the response. But then what we're actually still doing here is human is sending message and AI is responding. It's not adding some tweak to it. So how do we make use of other things that we'll have to actually make the AI to execute stuff for us? How do we do this? How do we make this AI to execute other things for us? Not just, we've built a simple graph here, not just from just simple LLM code. So let's look at agents. Okay, so let's look at the agents. Now I know that we've queried this with arithmetic functions, and it was able to do few things as arithmetic function. But let's say that I want to build an agent that does arithmetic function. That would be the project we'll be doing here now. Okay, an agent that does arithmetic functions. So this is just the simplest way for you to understand how this functions. So I have two functions here, the multiplication and addition. This is just a simple Python function that takes two variables, and then this multiplication returns their product, and this returns their sum. Okay, this returns their product, and this returns their sum. So to use these as tools, I need to bind them to the LLM. See where I defined the tools. I created a list of tools. This is a list of tools. And then I binded these tools to the LLM. These are LLM. LLM don't bind tools. And it returns an instance, which is LLM with tools. Now, this LLM with tools already has these two tools with it. So that if you actually want to do anything, it can reference these two tools. Seeing this as tools that it can actually make use of. Okay, so we'll define an assistant. We'll just call our function assistant. This is just same with what we did here. I just same thing with what we did here. Okay, just same thing with what we did. But the difference is we are not using LLM tools because we have binded our tools. LLM. Okay, so LLM tools, and we are okay, we are invoking it with these messages. Then we are returning the response to that message. All right, so let's run this, and then I will also run. So let's now build the graph. Let's see how the graph will look like. So building the graph, two other methods I will be importing, which is the tools condition and then the tool node. So this tool condition is a function that what the job is. Okay, I will show you what the job is. Let's come to where they are. So we add the two nodes we need here. Remember in our first graph, we only added one node, which is just the assistant node or the LLM node. But here we're adding two nodes. We're adding the nodes that we have the tools, and then we're adding the node that we have the assistant. The assistant is this man. Okay, and then the node, we're adding it with these two nodes. And then our workflow will flow from start to assistant. And then from assistant, it will not be checking the message you ask the LLM. If the message requires making use of a particular tool to execute the instruction, this is where the reasoning comes in. So it needs to reason. What does it need to get this thing done? If what it needs is in one of the tools, it's going to return tools. This, what happens here is it is going to go from this assistant to these two conditions. So these two conditions will help the reasoning to know whether it's the LLM is trying to make a tool call, whether the LLM is trying to make a tool call, or it's not trying to make a tool call. So that's just what happens there. I saw a message. Yes, this is Python programming. Okay, this is Python. So, and so from the assistant is going to go to the tool condition. So these two conditions will return two things. It will return tools and end. So when it returns tools, you're going to go from tool to end. And when it returns end, then the graph should end. You compile your graph and then you run it. Okay, let me display this graph instead of just printing the manual code. So we display image. What's that? So I have graph dot get graph dot draw image. So and let's see how our graph looks like here. So this error is here again. All right, so I'm going to show something. This line graph that I'm making use of a particular API, a Mamed.life. That is with this, so that you'll be able to draw the graph. But in case you are getting this message, just print the Mamed code, run it with just print the Mamed code, graph.get graph.draw Mamed. Then we'll go to Mamed.life. Okay, so go to Mamed.life. Then we'll copy this code. We'll paste it here. And then we'll see our graph. So this is our graph. This is what we've built. All right, so some explanation here. So when you look at this, you see how this dotted line goes. This shows that there was a condition here. This showed that there was a condition here. Remember, from our assistant, we went to the two condition. So from assigned to go to the two conditions. So if the two condition returns two, it's going to go and execute the twos. But if it doesn't return two, if it returns end, it's going to go to end. And so what we have here from two, it will end. So we just have this, just the condition of what we have here. Okay, just like you can see what we did from assistant, it goes to the two condition. If it returns twos, it execute twos. If not, it should end. And then let's remember that our tools, which are these tools, is what we binded there, which are this and this. So since we have built our graph, now let us run this message. Let's say add 5 and 6. Add 5 and 6. Let's see what we are going to get. Add 5 and 6. Now, let's observe what is happening here. You see that this was the human message. Now, the AI returned the 2 core. Okay, the AI returned the 2 core. And what was the 2 core? It was addition, because the instruction we saw was add. It was addition. And the 2 variables are 6 and 5. And this is the 2 message. The 2 now executed and returned the 11. So this is just a 2 in action. You see that it's not just the LLM that is not giving us the response. A 2 is now working. Our LLM is still there, but a 2 is now working. So I can say multiply 5 and 6. Okay. Let me say multiply 5 and 6. And let's see what will happen. So you see it's called the multiplication 2, and then it was able to execute this. Let me say divide 5 and 6. Let's say divide 5 and 6. So, and you see that I don't know whether you will see something. So this AI already understands that its job is to perform arithmetic functions. So it's trying to call this divide 2, but there was no 2 found. So it's trying to call this, but there was no 2 found. Okay, there was no 2 found. So apart from doing this arithmetic function, let's try to ask this AI some question that is not arithmetic function. I can say what? So I can say what is agentic AI? All right. So you see that I asked it what is agentic AI. It was able to pass from the human, and then the AI got me a response directly without calling any tool. Now, this is the reason. Let me go back to our graph. Now, this is our graph. When the question comes there, this AI now does the reasoning. This is where the reasoning comes in. It reasons to know whether it needs any tool. Remember, it already has these tools, and it knows what these tools are doing. So it checks to know whether it needs any tool to execute what it wants. If it doesn't need any tool, it just executes it and just ends. But if it needs tools, it now use its hands to coin the message it's sending to that tool, so that the tool will be able to do what? Execute its function. So that is what we are having here. Okay, so let me add let me ask it that our question, the last question we had, add 5 and 6. Okay, so I want to say something. So now you see that our graph ends at this 2 message. Look at our graph. From the 2, it ends. There is no other reasoning. There is no second reasoning for the, there is not, we don't have what we call chain of thoughts, okay? The AI doesn't know if, the agent doesn't know if it has gotten to its final destination or what. It's just giving us an output. So we need to add kind of a chain of reasoning, a chain of thought to this system. So how do we add that chain of thought? So this was the graph we had before. But what we did here now is we are now passing this tool back to the assistant. So what it will do is when the tool is done executing, it will pass this output back to the LLM. So the LLM we can now know if the job is done or it needs to make another tool call. So that is just what we have here. So I'm going to build this other graph now. Let's see. So let's visualize how the graph looks like. All right, so this is how the graph looks like. So you see that unlike what we have before, the two is just going to the end. But here you will see that the assignment is coming to the two and the two is going back to the assistant. So it will be able to execute something more meaningful. Okay, so we're now asking the last question that we asked. You see that here, look at where it ends at the two call. But here it takes it back to the AI, and the AI was able to give a response that the sum of 6 and 5 is what? Is 11. Okay, so that it's able to execute this agent. Now, let me ask you that trivial question I asked it earlier. Let me say divide. Divide 6 and 5. Let's see what will happen. So this is the human message. It made a two call, and it went to call multiply because those were the tools that it has. But when this output went back to the AI know that this is not what it should be. Rather, it now uses its own hand to execute this since it knows that it doesn't have a tool to do this. This is just how the reasoning, the chain of thought comes into play in the agent. This is how the chain of thought comes into play in the agent. Okay, so I can ask it a lot of questions that will make it to reason, come back, and then send back to the AI tool for further execution. So let's just say, let me say add 10 and 37. Then multiply the sum by 20. Okay. So let's run this and see what will happen. All right. So it's made two call here. It makes a double two call. It's calling addition and it's calling multiplication. These are the two calls it's making. So the addition is passing 10 and 37, which is what we have here. And when you add 10 and 37, we're going to have 47. But here, it's making another two call, calling multiply with 57. Let's continue going down. The two calls has made an output. This return 47 and this is returning 114. So, and oh, it's not supposed to. Okay, this is returning 47. So when it runs this, it's getting, let me press my calculator. Let me know that this is correct. No. Let me retweak this question. I think the question, because there are a few other variables I'm supposed to set, but they're not here. But let me retweak this question so that to be able to run this execution very well. Oh, there should be an error somewhere. Hold on.
Hello, good evening. Sorry, can I see something?
Okay, yeah, go ahead with your question.
I mean, that prompt that you gave it, is it possible for you to add something like "and" so that it will understand that I need to complete this task before this other
Hmm.
task? Because from the output, what I'm saying is
Hmm.
replacing the argument with this one, the last argument you gave, that's 10.
Okay, I get you, but I'm coming. All right, so I'm just trying to formulate a system prompt for the AI. Okay. All right, so
Sorry.
we are here.
Hello.
Yeah, I'm with you.
Please, another way I was thinking, is it possible to, instead of
Hmm.
returning the actual numbers for add and this in multiply, you could actually multiply
Hmm.
strings so that you get
All
to
right.
debug it from there.
Okay. Don't worry. We are more precise now. Okay. So earlier I didn't set a system message. Just like I mentioned earlier that AI works with prompt. Most times you need to actually prompt them very accurately to perform your function. So this is a system prompt telling the AI who it is. Okay, so if I ask this AI who it is, it's going to give me a replica of what I have here. So I'm telling it the job is supposed to do. So this will enable it to understand the context. I talked about context earlier, to understand the context of what it needs to do to execute. All right, so we didn't have that earlier, and that's why it's actually messing up a little bit. But let's look at what it have here now. So the same question that was passed here that was that the tools it was messing up how it was actually passing variables, but now it's more precise. It understands what it needs to do. And the question, these are the two core. And then this is the output, and it is accurate because 10 plus 37 is 47. And when you multiply it by 10, you get 470, which is what we have here. That is this question. Okay, so we can retweak some of these questions and act it, and it's going to do what? Execute it. Why understanding who it is? Just like I told you now, let's take this message. Let me ask this AI, who are you? So if I say you, so it's going to tell me who it is and what it does. Are you with me? So I'm an arithmetic assistant to arithmetic functions. How can I assist you? So this is just telling going more deep, as in being more precise in context for the AI understanding what it should do. So from this particular prompt, there are so many instructions I can actually give this agent now on what it can perform. So from what we've seen now, we've actually built an agent that can actually perform simple tasks. We've added some arithmetic function. Here currently, we'll just have 2 arithmetic functions. Okay, so we can just try to, let me add divide here. So I'll say then divide the output by 10. Let me just add divide here. We know that we don't have any tool that performs division. So I'm just trying to test our agent, and then you actually see the different things that it can actually do. So you see that it actually called the tool multiply, but it didn't perform, it didn't make use of what the output that this tool gave it. It knows that this is what you are supposed to get. So, and it's did this for you. So you can on your own add more tools here. Like the only 2 tools that we have here now is the multiplication and the addition. You can add division and subtraction and other things. So the same way this thing works, that is the same way when you want to build an agent that does real-time web search for you, that you want it to search the internet. Just define the function here and then add it to your tool, and then you go to be able to do that and then give you the output. So this is just you understanding how the agent should work. All right, so that is what we'll be stopping for now for today. So I know that we'll have a whole lot of questions, so I'll be attending questions right now.
Hello?
Yeah, I'm with you. So I'm actually done, and I'm waiting for questions. I know that a lot of us will have questions. So please, if you have questions, can you raise up your hand? Then we'll... Okay. Victor is back. So Victor, take over.
All right. So thank you very, very so much for this insightful session. I mean, so I'll quickly go through with you, and then I'll try as much as possible to start the questions. So first, I have Mr. Clement. You can go ahead and ask your question.
Okay. Can I go on?
Yes, you can.
Okay, but your voice is actually very low. Please, thank you very much, Sir Felix Ipiamaka. The class was actually very, very, very resourceful. My question goes thus: what if you mentioned these tools being giving users or maybe engineers or developers the ability to add their own this thing? Is it their own reasoning into AI's reasoning? What's in a scenario that the tool you need, for instance, is not a function that returns one plus one or 2 plus 2? Maybe your own tool for instance, has to be with data. You want AI to be restricted to a particular data. Let me say, for instance, you are handling a school database and you want to build a system that if the parents chat up with the school data, the school system, and say, what is my child's grade? It should be able to answer based on the school database that you fed to the AI without going outside that boundary. How do you achieve this?
All right. So, like you can actually see here now, the tools that we find here is just addition and subtraction. The same way that these tools are performing addition and subtraction, that's the same way that I can define a tool that searches Google and gets a response. So if I ask it something that the AI doesn't know, it will actually go and search Google and then get a response and then use the AI to now respond to me. I will know that our ChatGPTs and Gemini, they do perform real-time web search these days. Even DeepSeek, all of them perform real-time web search. It is not the LLM that is doing that. It is the agent that they have on that chat app, on that chatbot that is actually performing that for you. Okay, it's the agent that they have there. So this is just a typical example of what an agent does. You can define any tool at all. It's not your ability, just like I said earlier, the um, um, the AI performs its function at the discretion of the tools. That's with the tools it has at its own discretion. So the more tools it has, the more function it can actually perform. So you understand that what the AI does is basically the reasoning, and then is the tools that it uses to perform tasks. Just like you as a human, you have your brain, and then you have a lot of tools that you can actually use to go to farm. So you'll be more productive, or you're more useful than someone that has lesser tools to work. So this is just how all these things work. So you need to define the tool that will perform that task, and then the AI will now help the tool to be more precise in the context and make sure it's not going out of bounds or hallucinating unnecessarily.
All right. So, can I also add to what you said?
Go ahead.
Yes. So, from a very standpoint perspective, let me say, software engineering perspective. Let's talk about a little bit of technicality here. So let's look at database schemas. Let's start from this. For example, you know that every student in the school has a unique ID, right? And from that ID, you can use it to access the student code. So actually, when you are declaring a function or you are declaring a tool, okay, so you know that each chat, right? Each chat has a unique conversation ID, and you can use that conversation ID to take out the student ID. So from there now, it's easier, or let me say it's good for it such that you want to now prompt the LLM something like, okay, what is the grade of my student, or what is the score of my child, or what is my student score? It will be easier for the agent using a particular tool to first extract that ID, that particular student ID. So after extracting that ID, there's another tool now is going to call upon completing this one to take data from the database. So after that, there's another tool to call to filter out information that we don't want to provide to the LLM, let's say like sensitive information or email or whatever. Then so that another way is that you can pass this information. It means writing functions to actually get the response, let me say from the database, and then take out like pass out the information we don't need. And then you can even pass it to another LLM. So in most cases, you can have components, and each of these components is like an LLM passing a response to another LLM, or a tool passing a response to another tool. So basically, that is how it works. So you want to go step by step, step by step, step by step. You already have like from then the final data is now passed to the best LLM, which is now like the brain now. It will then summarize and then pass it to the viewer or parent. That's why you'll be able to that is why you'll be able to see detailed information about that's how you're able to get detailed information about the particular class or the student in the embedded system. So far, try to answer your question.
Yeah, I'm good. I'm good. Thank you.
All right. So next um we have I'll just pronounce your last name or something. Because people hope I'm correct with your name. Yeah, you raised your hand for a while now. Yeah, maybe.
That is Kosi Sochukwu.
Oh, first is
Yes,
so
thank you very much for that.
Kosi Sochukwu, please.
sorry,
Good
I really
evening,
sorry.
everyone.
Yeah, good
Yes,
evening.
thank you so much for the session. It was really very resourceful. But then I have some kind of confusion. Like with what you've taught now, I want to know as in, this is actually the same thing I can do, like querying the normal public ChatGPT and all that. So what's the essence now? Like, the lesson is for us to know how those things work or how to build them. That's one. And two, if it's possible for us to get this script that you used in class. Thank you.
Okay. So thank you very much for the question. So
So,
okay, continue.
Kosi Sochukwu, yeah,
Yeah.
the essence is for you to learn how to develop them. Okay, so that is the essence of the class. It's not just knowing how it works, just for you. Just like as we did a code demo here, you've actually had an overview of how this thing works. When you get across this code, you run them and then try to add your own tool. This is just the fundamental building block of agent. If you can run this and understand how this works, you can add your own idea. Just like I said, we only have addition and multiplication here. It's very easy for you to add subtraction and division. You can even add some other arithmetic function. Now, try to remove this particular tools that we have here. Define your own tools according to what you want to do. Add it to this code and then see the magic it can actually do for you. This is just how the whole thing is.
Okay. Thank you. But then another question, please. The API that you got, I don't know whether it's for free version of the open AI this that you picked. So take for instance with that now, can you query and get a answer of the paid version? Like can it give you an in-depth answer like a paid version can give you?
Okay, what I did now, I have a credit in my account in OpenAI, and all these things I did now, they are taking money from there. All these things I did now, they were
Okay.
taking money. They were taking money from my credits for me to be able to run this. Are you with me? So it's actually a paid version. Just like I showed us. Okay, I don't think I showed us this. Let me. I think I did. Let me look for it. Okay. This. Okay. All right. So this is from OpenAI. These are all their models, and this is just the cost. This is for input token. This is for output token, and each of these is per 1 million token. So once you've taken up to 1 million token, then you saw when I showed you the metadata, you saw the input token, the output token. That is how it calculates the token, and then these are their billing. Currently I ran 4.1 nano. So there are different models here and with their different price. This is their most costly model. The O1 Pro is their most costly model. I don't think there's anyone more costly than O1 Pro. Okay, so O1 Pro is one of their most costly models. Then one of their most reasoning model is this O3 Mini and O4 Mini is one of the best reasoning models that they have. And then this O3 is another organ on its own that is doing very, very, very well. So let me see if we see those here. So it's just for you to choose the particular model that you want to use in OpenAI. The way it is in OpenAI, that's where it's in both Gemini, Cloud, Group. You log in, you fund your account, then you'll be able to make use of some of the. Though OpenAI, the first time, if you open the account for the first time, you can create API key and it will be going. Yeah, but it's very limited. It's very limited. Maybe after a day, it might stop. So, and you will need to fund the account. So I have credit here now. And that's how, so these are some of their models and what they do. So the O3 models is their most powerful model. Their O3 models are the most powerful. Then O4 is also very good in reasoning and all that. So, and you can now look at their pricing and then say this is the O3. And this model here does a lot. This O1 Pro. Yeah. So, and GPT 4.5 is also on testing. Let me see, GPT 4.5 is not yet. GPT 4.5 is on testing right now. So, you just say, hey, okay, look at it. GPT 4.5 preview is on testing. This 4.5 preview, okay, it's on testing now. It's not fully released, so you can run this and then give them your feedback. Say, okay, this is what it does. This, then they can keep fighting it until they get what they want. So that's it. I hope you are clear now, Coach Sochukwu.
Yes, very clear. Thank you.
You're welcome. So I think Dami Lola has a question.
Yeah, so I think there is she dropped the chat here. So are you in the group so I can reach out to you?
Hello. Hello. Can you hear me?
Yeah, go ahead, Dami Lola.
Okay, thank you, Mr. Felix. Your session has been very resourceful. I have a few questions. One of the questions is that I missed out on the first part of you creating the agents. That is, I missed the first part of creating it, the propagation level. Then I also want to know the Python library you're using to create the agent, if it's actually if actually you are using a library. And also I want to find out, can we also build these agents on other LLM, such as DeepSeek, Gemini, and other open source LLM? Those are my questions.
Please, can you repeat your second question, please? Your second question.
Okay.
There's this last question you asked now.
Okay, I want to find out the if there is a particular Python library you're using to create these agents.
I got this one. I mean, the last question you asked.
Okay. The last question I asked is the fact that is it possible to also build these agents on other LLM apart from OpenAI?
All right. So I worked with LangGraph and LangChain. Okay. So they are quite popular for building agents. There are so many other ways of building agents. There are many other. I think OpenAI released something a couple of weeks ago building agent, but I'm yet to text them. I'm yet to text theirs. And so many companies are building tools and frameworks for that. So you can check any of them out. But currently LangGraph is leading. That's for your first question. Yes, you can build with any LLM of your choice. You can even build using open source LLM like Llama, Gemma 3, Llama 2.5, Llama 3, DeepSeek, R1, and Mistral AI, and a whole lot of them. You can build with any of them if you wish. You can build with any of the open source LLMs. Okay, so it's just for you to know what you want to do and then to go ahead with it. So, like if you come over to the launching.com, so this is how to set up a chat model. There are various ways of setting up a chat model in LangChain. I use one of the methods. So these other methods, the library I called is different from the library they use there. But this is just what happens under the hood, okay? This is what happens under the hood. So you can actually set up any LLM you want. This is how you can set up OpenAI. If I don't want OpenAI, I want Anthropic. This is how I can set up Anthropic. If I want Azure, this is how I can set up Azure. But Azure, you must have Azure account and OpenAI account as well, because Microsoft works with OpenAI. This is how you can set Gemini. This is how you can set Group, and a whole lot of them. This is how you can set Mistral. So just come here and then play around with them. But you know that anyone you are setting up, we have the API key. So I believe your question was answered, right?
Yeah, but if possible, can I see the first part of your the
Is
scripts?
it the code?
Yes,
They
the
will,
scripts.
this code will be shared. You guys will get this. Okay, so
Okay. All right.
so I don't know if other persons. Okay, Mr. Hannah is raising up his hand, so you can go ahead. I'm not sure he's there with us. So, Mr. Hannah.
Hello. Sorry. Good evening.
All right.
Can you
Good
hear me?
evening. Go ahead. Yeah.
Yeah.
Fire.
See, concerning this, is this coding actually necessary? Can't we just like connect API? Like, I don't know. Like, I don't know if you get me. Is it necessary to really use this Python coding stuff to build? Are we building it from scratch, or we can just like use tools and just connect. You get? I don't know if you understand. Hello? Are you hearing me?
Yeah, I am with you. I'm with you. I got your question. Just when you are done,
Uh-huh.
then I will respond.
Yeah. I'm done.
All right. So, lang chain lang graph is basically you write the code. I think there is one new platform. There's one new framework that came out. I think that barely 2 weeks in the market now. Lang flow. So I think this is kind of drag and drop, but I'm not quite sure. Okay, so but what we have basically now is writing code, but then no matter what you want to do, you definitely need to write code. That's just the truth. When you're writing the code, you have control over whatever you are doing. You did want to, you be in charge. That's the thing. When you write the code, you be in charge.
Okay. So we can instead of we cannot just connect like ChatGPT API to something else, like the way this AI agent is
I
now. But most
believe,
of the
I
people,
believe, I believe that most of all those things will come. Definitely, they will come.
okay,
They will come.
no problem. Thank you.
You're welcome.
Yeah.
So I don't know whether we'll have any other person that is asking question. Otherwise, I'll end my screen. All right. So thank you very much, you guys, for it was a good time with you guys. So and I
We have,
believe I believe we enjoyed the class.
can you hear me? We had
Yeah, I can hear
one more
you.
last. Yeah, so the question was, can we build responsive AI agents? I think that
You
was
said
that
the
was
question
the,
is what?
can we build responsive agents? That was dropped in the chat.
Yes, we can build responsive agents. We can build responsive agents. As a matter of fact, I have some of the projects I've done recently. I have a very good agent that performs real-time web search, which I'm trying to upgrade to a multi-agent that can perform deep research that academians can be using to make research for different topics and all that. These are agents. Valve, no, it's not Valve, it's Visa. Visa, Visa did a demo of their agentic AI system on their platform where you can perform transaction just with a blink of an eye. Are you with me? What you just need to do is to just automate it and then the AI will do the whole job. The only thing you need to do is approve. When it needs you to approve, you just click approve and it does the whole stuff for you and you don't need to move, you don't need to do anything. There are a whole lot of agents out there. People are building agents. You can build uh, a full-time assistant agent that can make schedules for you, send reminders to those you have meeting with. What you just need to do is to know that you have meeting. And when you are in any meeting, if it's an online meeting, it will read the meeting, transcribe the meeting, and then know the output. It will make notes. If it's going to send it to anybody, send it to the person directly. I don't have a problem. So these are just tell it what you want it to do. There is a whole lot of responsive systems you can build with agents, a whole lot of them.
I mean, thank you very much. That's answered the question. So I would like to. I don't know if you can hear me clearly. Can you all
Yeah,
hear me?
go ahead. Yeah, go ahead.
Okay, so I would like to look at basically the flow of the program is that we're supposed to give assignments on each day. So I would like to share the first assignment. I don't want to like share my screen. So basically, we are going to for the end of today, we are going to do a website tool. That is a website function, right? Just a function that anybody can get that function, anybody can get that file, and then integrate it to any LLM, and you have the ability to search. So basically, you are just writing a function, something that goes to the web, do website, and then return the result. It's very simple like that. I hope you understand the assignment. We are not in the group, join the group. So I'm going to drop a detailed, a more detailed. Basically, there's no much this I have to explain again. It's just something to go and search the web and then return search results. So you give it a particular query, if you go to the web, or if you run that function, it goes to the web, go does a website and returns it back. So our program continues tomorrow, same time, 4 p.m. Watch. Thank you everybody for joining. This session is recorded and it will be shared on our YouTube channel, including Python Anambra YouTube channel. So for those who want to reach out to contact, so please, I'm dropping a link now. Do well to join the group so you can interact and connect with other group members, and then even if you want to collaborate on your project, you are free to do. So since you don't have any other questions, the assignment is I think the assignment is to build a search tool in Python. So basically, that is a function. Yes. So here is the assignment. The assignment is to build a search tool in Python. Right? So build a search tool in Python, something you can use and then integrate. I'm going to share the link to the GitHub repository so that you can upload or make a pull request so that you can review your code. So at the meantime, since you don't have any other questions, thank you everybody for joining. We continue again tomorrow, and then you can call it a day from there. All right, thank you everybody. Bye. So I'll end the recording.